Right, I'm going to take a look at a few more linear programming problems from the notes. So I'm starting out here with constraints that are all just at x or y values. So I can start with drawing my lines. So starting with x is 2. Remember, I'm just doing equals 2 right now. These are all going to be solid lines. So that'll be my first constraint. Then where x is 5, doing my best without markers to keep it as straight as possible. Then I've got y is 1, going across this way, and y is 6, like right there. So now that I've got my constraints, I just need to make sure that I am using them all correctly. So if x is more than 2, going this way, but less than 5, going this way, then it's more than 1, less than 6, so I end up with this area in here. Next thing I need to do is I've got to find my corners and see which one's going to be the maximum versus the minimum. So I'll set up a little bit of a chart here. So for my corners, then my formula that I'm using is 3x plus 4y equals c. So let's go label our corners, and this one goes pretty easily. I've got from over 2 up 1, so 2, 1, then over 5 up 1, then over 2 up 6, and over 5 up 6. So I'm going to put those on here. 2, 1, 5, 1, 5, 6, and 2, 6. And then all that's left to do is I'm plugging that into my equation here. So 3 times 2 plus 4 times 1 would give me 6, 7, 8, 9, 10. Then 3 times 5 plus 4 times 1 would give me 19. Then I'm going to do 3 times 5 plus 4 times 6. So 24 and 15 be 39. And last one, 3 times 2 plus 4 times 6. 24 plus 6 would give me 30. So with those, I'm just going to look for the highest value and the lowest value. So it looks like 10 is my minimum, and 39 is my maximum. So the minimum value of C is 10 when x is 2 and y is 1. Then the maximum value is 39 when x is 5 and y is 6. And it kind of makes sense with the graph here that if we look, our minimum value was down in this part, maximum value was up here. long as it, kind of works out that way, you end up with those being in a similar area. It just kind of depends. So let's look at one more. I've already set it up, and knowing that I'm probably going to have numbers that end up a little bit larger, I've laid it out this way. So I already know x and y is going to be greater than or equal to 0. So that means nothing's going into the negative on my axis. Next thing I need to do is figure out a couple points for these two lines here. So for 4x plus 3y, I'll work that out up here. When x is 0, it leaves me with 3y equals 24. So divide both by 3. It means x or y would equal to 8. And then when y is 0, then the x is going to be before x equals 24, so divide by 4, and that would give me 6. So let's go ahead and graph that line. I've got over 0 up 8, gives me that point there, and across 6 up 0 gives me that point there. Again, it's greater than or equal to, so I'm doing a solid line that goes through those 2 points best I can do. Got it right there. Then I'll do my next one. So just finding my zeros. So when x is 0, looking down here, if x is 0, then 3y equals 15. Divide both of those and I get y is 5. And then when y is 0, I just get x is equal to 15. So 0, 5 is right there. And 15, 0 be way over here. Next step is going to be to decide if my axis here, so I'm testing points to see which would be true. So if I test the 0, 0 here, that says, would say 0 is greater than or equal to 24, which is false. So that means for my first line that I did, it's going to be going away from the axis. And my second one says 0 is greater than or equal to 15, because I just made x and y 0, which makes this whole left side 0, which is also false, which means this one as well is going to be going away from it. So I'm not hitting this space here, this space, or even this one here. The area that I'm looking for is all this out here. And so when we look at this here, this is what we'd call an unbounded region. Which just means that there is no maximum, because this could keep going up and up and up forever. So with there being no maximum here, I can just write down at the bottom, no maximum. Then the last thing I've got to do is test my corners. So looking at this, I know I've got a corner here of 0, 8. And then I've got a corner over here that is 15, 0. But I've got, it looks like, a part right here where I do not have the corner yet. So we've got to figure that out before we can finish this up. So what I'll need to do is either do elimination or substitution or set them both as y equals and solve and figure out this corner. So when I'm looking at these two, I notice I've got 3y for both of them. So my plan is going to be to do some elimination, which would just say 4x plus 3y is equal to 24. Then I'm going to flip the signs on all of these, say negative x minus 3y equals negative 15, which gives me the y's that cancel out. So that would say 4x minus x would be 3x equals 9. And divide that out, and my x value would be 3. Then I can take that 3, plug it into either one of my equations. So if I plug that in here, and again, I'm just finding where this corner is, so it's a system of equations, seeing where those lines meet. So 3 that I substitute in for x plus 3y equals 15. Subtract 3 from both sides gives me 12 equals 3y. And divide both those out, y equals 4. So once I've got those two, that means this point would be 3, 4. Now I just need to test my corners. So, kind of running out of room here, but should be able to test a few of the corners. So my corners, and then my formula would be 6x plus 7y equals c. My corners would be 0, 8, 3, 4, and 15, 0. So remember, I have no maximum, so I'm just looking for the smallest number I can get. So 6 times 0 plus 7 times 8. So nothing plus 7 times 8, just be 56. Then 6 times 3 plus 7 times 4 give me 18 plus 28, 38, 46. And last but not least, well, maybe least, I guess we'll see. 6 times 15 plus 7 times 0. So doing 6 times 15, if I know 6 times 10 is already 60, then 6 times 5 is 30, it's 90, but looking at that, I know it's going to be more than both of those, so even if I don't finish that out, I should know that my minimum would be this one here in the middle. So the minimum value of c would be 46 when x equals 3 and y equals 4. Okay, so I know there were a lot of steps going through this one, but this is doing our system of equations from the last unit and then building up from 3.1 and 3.2, finding our shaded area, the inequality, and then just plugging it in. So a lot of steps, but all stuff that we have done and that you can do as you work through this.